Good morning, students. The previous class we have seen the reduction formula 1, that is integral 0 to pi by 2 sine power nx dx, otherwise integral 0 to pi by 2 cos power nx into dx. So today we are going to see the reduction formula 2. It involves both the trigonometric functions, that is sin x and the cos x together. Okay, so see, first there are three ways we can use the reduction formula. The first one, depending on the powers of the trigonometry functions. So see now here 0 to pi by 2, integral 0 to pi by 2 sine power mx cos power nx into dx. Here m and n are even, both m and n are even. If it's so, how to write the formula for integral 0 to pi by 2 sine power mx cos power nx into dx. Okay, keep that in mind. The powers m and n are even. So first you have to start with the power of cos x. So in the numerator you have to write n minus 1, n minus 3, n minus 5, etc. You have to complete the numerator is 1. Okay, so you have to subtract the odd numbers from the power of n, the power of cos x. So see the numerator alone, n minus 1, n minus 3, n minus 5, till you have to complete the numerator is 1. At the same time, the denominator of the first term is m plus n. The second term is m plus n minus 2. The third term is m plus n minus 4. Okay, so after brought the numerator is 1, then you have to start with the power of sin x. So here the sin x power is m. So the numerator you have to write m minus 1 and denominator is m. Here m minus 3 divided by m minus 2 till you have to complete 1 by 2. After getting 1 by 2, you have to multiply with pi by 2. Okay, so see exercise 9.6, the fifth subdivision, integral 0 to pi by 2. You have to see the limit varies from 0 to pi by 2 sine squared x cos power 4x into dx. Okay, so both the functions are involved and you look at the power of both, that is even 2 and here you are having 4. Okay, and the limits varies from 0 to pi by 2. So you are going to use the reduction formula 2 first time. Okay, so what I said, you have to start with the power of cos x. So it is what? 4. So 4 minus 1. What is 4 minus 1? That is 3. Next 4 minus 3. 4 minus 3 is what? It is 1. So here while explaining the formula, so you have to write the numerator till it arrived 1. So here 4 minus 3 is 1. Okay, so you have to stop the power of, using the power of cos x. After getting the numerator is 1, you have to start with the power of sine function. So here the sine power is what is it? 2. Okay, so here you have to start with the numerator is what? M minus 1. So therefore it is m minus 1. M is 2. So 2 minus 1 is 1 and divided by m. You see that? M minus 1 divided by m. So it is 1 by 2. So you have to use the power of sin x till you have to arrive 1 by 2. Here you got 1 by 2. So next you have to multiply with pi by 2. Okay, see again. First, here the integral is 0 to pi by 2. Sine and cos both are involving, both powers are even. So first I said to start with, what is that? The powers of cos. So here the cos power is 4. So what you have to write? First 4 minus 1. What is 4 minus 1? 3. Okay, next into next term numerator I am writing 4 minus 3. 4 minus 3 is 1. And here you have to write the denominator. Denominator is m plus n. So it is 6. Okay, here m plus n minus 2. So 6 minus 2 is 4. So you have to continue till the numerator 1 is reached. So here 1 is reached. After that you have to use the power of sin x. Here sin x power is 2. So here your term is, you look at this. So start with m minus 1 by m. What is your m? M is 2. So m minus 1 is 1 divided by 2. Okay, so you have to use the power of sin x till you arrive 1 by 2. So here the first term itself is 1 by 2. So both the powers are even, means after getting 1 by 2 you have to multiply with pi by 2. So that's why I have written it is 3 by 6 into 1 by 4 into 1 by 2 into pi by 2. And 3 and 6 getting cancelled. So therefore it is 1 by 2. So if you multiply, it is pi by 32. Okay, keep that in mind. The reduction formula. So both the powers are even. So the numerator, you have to start with the power of cos x by reducing the odd number till you have to get 1 in the numerator. After getting 1, you have to start using the power of sin x. So how we have tried m minus 1, m minus 3 till you have to get 1. Okay, after getting 1 by 2, you have to multiply with pi by 2. Okay, you see the next one, reduction formula 2 second time. You see that if n is odd and m is any positive integer, that means m on the odd or even, anything may be. Okay, then you see that integral 0 to pi by 2 sin power mx cos power nx. So the power of cos is odd. M may be even or odd. If it's so, you have to use this formula. You see that the previously we have seen both the powers are even. Here the power of cos x is odd. The power of cos x is odd. You need not worry about the power of sin x. It may be anything, odd or even. If it's so, you have to start with the power of n as usual. What do you have to do? N minus 1, n minus 3, n minus 5. It goes on like this. So you will reach 2 in the numerator. You have to reach 2 in the numerator. 2 if it comes, the denominator should be m plus 3. Okay, after that you have to write the term 1 by m plus 1. Okay, if n is odd, the power of cos x is odd, you have to start with the power of cos x. So it is n minus 1, n minus 3, n minus 5, like that it goes on, and it will reach, definitely it will reach 2. 2 is in the numerator, the denominator should be m plus 3. Automatically it will come. Otherwise you have to see this 2 divided by m plus 3. Okay, next you have to write 1 by m plus 1. Okay, you look at the exercise 9.6 7th problem. The limits varies from 0 to pi by 2. Both the sine and cos functions are involved. You see that here the power of cos x is odd. You need not worry about what the power of sine, whether it may be odd or even, no problem. You have to use this formula. So first you have to use the power of cos x. So here you are having 5. So first what you have to write, n minus 1, that is 5 minus 1 is 4. Okay, divided by m plus n. So you have to add these two. So 4 by 8 into here 5 minus 3. What is 5 minus 3? 2 divided by m plus n minus 2. So that is 5 plus 3, 8. 8 minus 2 is 6. So you have to continue till the 2 is reached. So here the 2 in the numerator you are having 2. See, 2 divided by 6. So what is your m? 3. 3 plus 3 also 6. Whether you can use this, the second term, you will reach in this form 2 by m plus 3. After that it has to be multiplied with 1 by m plus 1. So 1 divided by, what is m? It is 3. 3 plus 1 is 4. Okay, you see now, suppose, see the term here, 0 to pi by 2, it is sine cube theta cos power phi theta into d theta is given. So you are going to use the reduction formula. You see that the power of cos is odd. Okay, so I told you to start with the power of cos. So here you are having 5. So 5 minus 1 is 4 into 5 minus 3, it is 2. So I told you have to stop if the numerator is 2. Okay, so you have to stop using the power of which one? Cos x. Okay, you fill the denominator. What has to come? M plus n, that is 8. Here what you will have? M plus n, what is it? Minus 2. So that is 8 minus 2 is 6. Okay, you need not, hereafter you need not use the power of, what is it? Cos x. If you use in this formula, according to this formula, it is n minus 5. 5 minus 5, 0 will come. So everything will be 0. So if n is odd, the power of cos x is odd, means you have to get the numerator as 2. After that, you have to multiply with 1 by m plus 1. So that is m is 3. 3 plus 1 is 4. So this will be the answer. So 4 by 8 into 2 by 6 into 1 by 4. So this 4 and this 4 getting cancelled, and 2 and 8 if you cancel, it is 4. So the answer is 1 by 24. Okay. So it's a second reduction formula, second model. Okay. We are moving to the reduction formula 2. Reduction formula 2, third type. If one of m and n is odd, you see that m and n, any one is odd, then you can bring the power of cos x is odd. Okay, you see that m is odd and n is even. Suppose the problem is like that. Suppose here m is odd, any one is odd, means you try to bring the power of cos x is odd. So here which is odd? M is odd. Okay, it is given if m is odd and n is even. So m is odd means this can be written as integral 0 to pi by 2 sine power nx cos power mx into dx. See, keep that in mind. Any one power is odd, try to bring the power of cos x is odd. So here it is given m is odd, so I have given to the power of cos x. Okay, so see now, so you have to start with the power of cos x. What is it? M. So the same way you have to proceed. Now it is odd. What you have to proceed? You have to start with the power of cos x by reducing the odd numbers. So in the numerator is m minus 1, m minus 3, like that it has to go. You have to reach the power of the numerator as 2. After getting 2 into 1 by n plus 1. So the power of sin x is n. So that's why n plus 1. The same way previously what we did, the same way you have to use it. Okay, look at this example 9.39 first subdivision. Okay, it's a example. Integral 0 to pi by 2 sine power 5x cos power 4x into dx. You look at this, the power of cos x is it's even, but the power of sin x is odd. So any one power is, what is it? Odd. So what you have to do? You have to bring the, not you have to, it is convenient for us to bring the power of cos x is odd. So I have interchanged the powers. sine power 4x into cos power 5x. How to do that? You have to use the power of cos x. So here what you are having? 5. So first 5 minus 1. What is 5 minus 1? That is 4. Next 5 minus 3. That is 2. You have to stop till the numerator is 2. Okay, so you have to stop using the power of cos x after getting the numerator as 2. Stop it here and fill the denominator. What is it? M plus n. So 4 plus 5 is 9. The next one, m plus n minus 2. So 4 plus 5 is 9. 9 minus 2, that is 7. You stop up to this. Then what you have to write? Into 1 by the power of sin x plus 1. So it is 1 divided by the power of sin x is what? 4. 4 plus 1 is 5. So this will be the answer. Okay. So the reduction formula 2, you are having 3 types. The first one, m and n both are even. Okay. Next one, the power of cos x is odd. You need not worry about the power of sin x. But any one is odd, you have to change the power of cos x as odd, then use the previous problem. Okay, so the next one, we are moving to the reduction formula 3, that is integral 0 to 1. You see that limit? Here you are having 0 to 1 x power m into 1 minus x power n into dx. So you have to get the limit as 0 to 1 x power m into 1 minus x the whole power n into dx. If you have to write m factorial into n factorial divided by m plus n plus 1 factorial, where m and n are positive integers. We should not use for negative integer, you have to use only for the positive integers. See the exercise 9.6, the problem number 8. Okay, see the limit. What is the limit? 0 to 1. Okay, x power m. M is what? 2. It's a positive integer. Here the term is what? 1 minus x the whole power 3. 3 is also a positive integer. Just write m is equal to 2 and n is equal to 3. So exactly it is a reduction formula 3. So the formula is m factorial 2 factorial into n factorial 3 factorial divided by m plus n plus 1. So 2 plus 3 plus 1 factorial. 2 factorial into 3 factorial divided by 6 factorial. Okay, so see now 2 factorial is 1 into 2, that is 2. 3 factorial is 1 into 2 into 3. And 6 factorial is 1 into 2 into 3 into 4 into 5 into 6. Okay, so here 1 into 2 into 3 getting cancelled. If you cancel with the 4 and 2, you will get 2 here. So 1 divided by 2 into 5 into 6. The answer is, what is it? It is 1 by 60. So here, you see, here you are having 2 factorial into 3 factorial divided by 6 factorial. So 2 factorial answer is 2, 3 factorial you keep as it is. Here 6 factorial can be written as 3 factorial into 4 into 5 into 6. You can write that according to the factorial formula. Then 3 factorial getting cancelled, and this 2 and 4 getting cancelled. You will get 1 by 2 into 5 into 6. That is 1 by 60. In this way also you can write. Otherwise you can expand the factorial fully, then cancel the term, then bring the answer. So we have completed the reduction formula. Okay, next we are moving to the gamma integral. You see that it is a improper integral. We'll have the value for that integral 0 to infinity e power minus x into x power n minus 1 into dx, exponential function and algebraic function. So this is called the gamma integral. It is denoted by this symbol. Okay, it is read at gamma of n. Okay, so the answer for this n minus 1 factorial, where n varies from 1 to 3 etc. Okay, you see that integral 0 to infinity e power minus x x power n minus 1, e power minus x. Here what you are having, you have to bring the base of the algebraic function x power n minus 1 into dx. This is called gamma integral. This answer is n minus 1 factorial. Using this, we are going to do the exercise 9.7. Evaluate the following. The first subdivision. Integral 0 to infinity x power 5 into e power minus 3x into dx. See now, e power minus 3x into, if you have 3x the whole power 5, directly you can apply the gamma integral. But here you are having x power 5. So, e power, what is it? Minus 3x. In that 3x you have to take it as t. Differentiate with respect to x. So 3 is a constant. The differentiation of x with respect to x is 1, and if you differentiate t with respect to x is dt by dx. So dx you have to bring it to the left hand side and 3 has to be brought to the right hand side. So dx is equal to dt by 3, and you have to change the limit also. Limit is in terms of x, you have to convert in terms of t. So x is equal to 0. X is 0. If you substitute 3 into 0 is 0. If you substitute x as infinity, you should not write 3 infinity. Infinity is indeterminate, so you have to use infinity. So you call the first problem. 1 implies integral 0 to infinity. See, what is your x from this? X is equal to t by 3. So in the place of x, t by 3 the whole power 5 into e power minus t. What is dx? It is dt by 3. So see, here you are having 3 power 5. The same way in the denominator you are having 3. So therefore 1 by 3 power 6 is taken out. So here you will have 3 power 6. How the 3 power 6 has come? Here you will have 3 power 5. Here you will have in the denominator 3 power 1. So it is written as 3 power 6. What will be the remaining? T power 5 e power minus t into dt. So t power 5 e power minus t into dt. So the constant is taken out. Integral 0 to infinity e power minus t power 5 into dx. You see that it looks like a gamma integral. See, this is the gamma integral. Its answer is n minus 1 factorial. You see the limit 0 to infinity. In our problem also the limit is 0 to infinity. E power minus x. Here you will have e power minus t. If you have the power as x, means the algebraic function base is also x. Here the power is t, the algebraic function base is t. So t power 5. So the 5 can be written as 6 minus 1 into dx. So the answer is what? 6 minus 1 factorial. That is 6 minus 1 factorial is 5 factorial. So the answer is 5 factorial divided by 3 power 6. So we'll move to the second subdivision. Integral 0 to pi by 2 e power minus tan x divided by cos power 6x into dx. So this has to be taken as method of substitution. First you have to take it. So tan x is equal to t. Differentiate with respect to x. Tan x differentiation is secant squared x is equal to if you differentiate t with respect to x is dt by dx. So secant squared x into dx is equal to dt. So the limit also has to be converted in terms of t. So x limit is 0 and pi by 2. You have to convert into t. If you substitute x as 0, here tan 0 is 0. So t is equal to 0. If you substitute x as pi by 2, tan pi by 2 is infinity. So this first integral can be written as integral 0 to infinity e power minus, what is tan x? It is t. So e power minus t, and 1 by cos power 6x. 1 by cos, it's a reciprocal of cosine function, that is secant power 6x into dx. You see that the limit and this term is in terms of t, but these two are in terms of x, so it has to be converted. And we have written secant squared x dx is equal to dt. So the secant power 6x can be written as secant power 4x into secant squared x into dx. So secant squared x into dx can be written as dt, but still this term is in terms of x. So the secant power 4x can be written as secant squared x the whole squared. Secant power 4x can be written as secant squared x the whole squared. Secant squared x can be written using the trigonometry identity 1 plus tan squared x the whole squared. Okay, so in the tan x we have taken as tan x is equal to t. So here tan squared x is equal to t squared the whole squared. So everything is in terms of t. So you have to expand using the formula a plus b the whole square. So a squared plus b squared plus 2ab into dt. So if you multiply e power minus t into 1 is e power minus t dt. So we have written as a separate integrals. So plus t power 4 into e power minus t into dt plus integral 0 to infinity 2t squared into e power minus t into dt. So here only the exponential function, the integration of e power minus t is minus e power minus t. The limits varies from 0 to infinity. It is a looks like a gamma integral. What is the answer for this? The power of n. Here the power of t is the answer. So it is a 4 factorial. And you see that in this integral the 2 is a constant. It is taken out. See the remaining is a what is that? Gamma integral. The power of t is 2, so it is 2 factorial. So if you apply the upper limit for the first term minus e power minus infinity, before applying the lower limit you will have minus, here also you will have minus, so minus into minus plus e power 0. 4 factorial is 24, here 2 factorial is 2, 2 2's are 4. E power minus infinity is 0, so the first term will become 0, here e power 0 is 1, so 28 plus 1 is 29. Okay, so we'll go to the second problem. If integral 0 to infinity e power minus alpha x squared x cube dx is equal to 32. The answer is 32 means, and alpha is greater than 0, find the value of alpha. Oh, so first you have to do the method of substitution. The power e power, that is alpha x squared, has to be taken as t. You have to differentiate with respect to x. Alpha is a constant. The x squared differentiation is 2x is equal to the differentiation of t with respect to x is dt by dx. So here I have arranged x in x alone, I kept it here into dx, that is equal to dt divided by the constant is brought to the right hand side in the denominator, dt by 2 alpha, and you have to change the limit. When x varies from 0 to infinity, your t also varies from 0 to infinity. See that x, if you substitute 0, alpha into 0 is 0, so t is equal to 0. X tends to infinity, alpha infinity the whole square, you should not write like that, so it is infinity. So therefore you take this problem, the left hand side, integral 0 to infinity e power minus alpha x squared into x cube dx can be written as the limit, there is no change in the limit, so integral 0 to infinity e power minus what is alpha x squared, that is t, and here x dx is dt by 2 alpha. So the x cube can be written as x squared into x into dx. So in the place of x dx, you have to substitute what? Dt by 2 alpha. So it is written here x dx is dt by 2 alpha. What is remaining here? X squared. So here you are having x squared. So what is x squared? T by alpha. So e power minus t, t by alpha. What is x dx? dt by 2 alpha. What is the constant? 2 alpha into alpha is alpha squared. Okay, so the 2 alpha squared is taken out. Okay, what is remaining? Integral 0 to infinity e power minus t, t into dt. This is nothing but gamma integral. So the answer is the power of t. What is power of t? It is 1. So that is 1 factorial. So 1 by 2 alpha square. So we have found the value of the left hand side integral. Okay, it is given that it is equal to 32. So therefore 1 by 2 alpha squared is equal to 32, and this alpha squared you take it to the right side as just in alpha squared, and 32 you have to bring it down. So 2 into 32 it is 64. So alpha is equal to plus or minus 1 by 8, but it is given that alpha is greater than 0. So therefore the value of alpha is equal to 1 by 8. Thank you, students.